The universe is everything, from the tiniest particles to the largest galaxies, to the very existence of space, time, and life. But how did it all begin? Scientists fed the oldest question in all of human history into the most powerful quantum machine ever built. Who made the universe? And what came back left a room full of physicists unable to speak. They were not expecting music and answer. They were expecting noise. Instead, the machine returned something none of them were prepared for. A pattern so precise, so deliberate, so impossibly structured that the man who runs the project, music, said a sentence out loud that no serious scientist should ever say. This is not a chatbot. This is not science fiction. And by the end, you will understand exactly music, why they went silent. The strangest machine. The first thing you have to understand is what this machine is not. It is not a chatbot. It is not a language model guessing the next word in a sentence. It is not the kind of AI you have been arguing with on your phone all year. So let me kill the confusion right now, because the words quantum AI send almost music everyone in the wrong direction. Your brain hears AI and reaches for something like ChatGPT. Drop that picture completely. The team behind this is literally named Google Quantum AI. And the AI in that name has nothing to do with chatbots or text or conversation. This machine does not think in music language. It does not think in words at all. It thinks in raw probability, in the deepest rules of physics, and it runs on a logic no computer in human history has ever used before. For decades, scientists chased music, a dream, not a faster computer, a fundamentally different one, a machine that would not just solve hard problems quicker, but solve problems that are flat out impossible for any ordinary computer. Problems so tangled in probability that a normal machine would need longer than the lifetime of the universe. Music, just to begin. That machine finally has a name, a quantum computer. And in December 2024, Google announced they had built one that actually worked. They called it Willow. Now stay with me, because this is the part that changes music everything. Every device you have ever touched runs on bits. Ones and zeros, on or off. Your whole digital life, every photo, every message, every video has been chopped into chains of ones and zeros racing through circuits. That is classical computing, and it is powerful. But it slams into a wall, a hard mathematical ceiling that no amount of engineering will ever break through. Willow does not use bits. It uses kits. And here is where reality stops behaving. A qubit does not have to be a 1 or a 0. Through something called superposition, it can be both at the same time, hanging in pure probability, neither here nor there until the instant you measure it. That single trick cracks open a space for calculation so enormous it makes every machine we have ever built look like a child counting on its fingers. Music and superposition is only half the secret. The other half is entanglement. Tie two qubits together and they become bound by something distance music cannot break. Touch one and the other answers in the very same instant. Not after a signal crosses between them. Not after a message travels. Instantly. Einstein hated this. He called it spooky action at a distance, and music spent years trying to prove it could not be real. He lost because it is real, and it is one of the most relentlessly confirmed facts in all of physics. Willow holds 105 of these qubits all running in music superposition and entanglement at once. And what Google showed the world in late 2024 should frighten you a little. Willow took a single benchmark problem, a calculation built specifically to push any machine to its absolute limit, and finished it in under 5 minutes. The same problem handed to the fastest classical supercomputer on Earth would take 10 septillion years. A 10 with 24 zeros behind it. That is not just longer than the universe music has existed. That is longer than the universe is expected to last. Long after the final star is burned out and everything has gone dark. A problem that would outlive the cosmos, solved before you could finish a cup of coffee. And believe me, that is not even the part that made the people in that room go silent. Borrowed from elsewhere. Because when Willow ran that calculation, something about the answer refused to fit inside the laws of this universe. It was not just fast. By one honest reading of the physics, it was too fast, faster than the physical resources inside a single reality should be able to support. The sheer amount of information moving through those circuits looked like more than the atoms and particles of one universe could possibly carry. And that is what pushed Hartmut Neven, the man who runs Google Quantum AI, to say the thing that rippled out across the scientific world. He suggested the computation was happening across many parallel universes at the same time. That Willow, by reaching into the deepest machinery of quantum mechanics, was borrowing power from versions of reality we cannot see, cannot touch, and cannot reach, and pulling the answers back into ours. I need you to hear where that came from before you laugh it off. Not a blogger, not someone chasing a viral clip. A physicist who has spent his career building these machines, leaning on one of the most seriously debated ideas in all of theoretical physics, the many worlds interpretation. It was first proposed by Hugh Everett back in 1957 and later carried forward by the Oxford physicist David Deutsch, one of the founding minds of quantum computing itself. The idea is this. Every time a quantum event happens, every time a particle drops out of superposition into a definite state, reality does not just pick one outcome. It splits. Every outcome happens, each in its own branch, all of them equally real, all running in parallel, blind to one another. Every collision, every decay of every atom, forever branching into an endless tree of realities. None of them more real than the rest. If that is true, and there are serious credentialed physicists who believe it is, then Willow is not a faster calculator. It is a machine that reaches across the boundaries of reality itself. So picture what these people were holding, a device that may compute in the multiverse, and then picture what they decided to do with it. They turn it toward the one question human beings have never been able to answer. Quick thing before we go there, because what comes next is the entire reason this story exists. If a machine that might be computing across parallel universes is the kind of thing that lights up your brain, do me one favor. Tap subscribe and hit the bell. That is the whole signal that tells us to keep chasing stories this big. Done. Now, let us walk right up to the question itself. The oldest question. They did not type a sentence into a box. There is no keyboard for a question like this. No text field where you ask a quantum processor about the origin of everything. What they did instead was translate the deepest cosmological and mathematical questions into the only language Willow understands, the language of quantum circuits, and probe the structure of reality from the inside. Stripped all the way down, the question was this. Is there something woven into the mathematical fabric of the universe that looks like intentional design? Is there a signature, a fingerprint that points toward a pattern instead of an accident? Toward something built instead of something that just happened to fall together? And here I have to slow you down, because this is exactly where every cheap version of this story lies to you. No machine handed anybody a receipt signed by the creator of the cosmos. No quantum computer proved that a God exists. That did not happen. And anyone who tells you it did is selling you something. What actually came back is stranger than that, and quieter, and in a way far more disturbing than a clean answer would have been, because the response did not arrive as a verdict. It arrived as a resemblance, a pattern that by every reasonable expectation had no business being there. Code in the cosmos. To feel the full weight of what they were looking at, you need one more piece and then the whole thing locks together. You need to understand error correction. Anytime information travels across something noisy, a radio signal, an internet connection, a transmission from a spacecraft billions of miles away, errors creep in, bits flip, the message rots. Error correcting. Music codes are the math that catches those errors and repairs them, so the original message survives the journey. Your phone does it thousands of times a second. Every satellite does it. It is the invisible machinery that keeps information from collapsing into noise. In 1995, the physicist Peter Shor proved that quantum information could be protected the same way, that you could wrap it so cleverly that even if some qubits got scrambled or destroyed outright, the information underneath would survive. And here is the thing almost nobody connects. Willow's real breakthrough, the one published in the journal Nature in December 2024, was exactly this. Google showed that as you add more qubits to Willow, the error rate does not climb, it drops. The machine gets more stable the bigger it grows. That result, music, is what genuinely shook the field. Now hold that, because this is where physicists stop talking and start staring. When researchers examine the structure of space-time itself, When they dig into the mathematical architecture of reality at its deepest level, they keep tripping over something they were never looking for. The universe looks like it is built on the same logic as a quantum error-correcting code, not as a poetic metaphor, mathematically. The physicist John Preskill and his colleagues have taken this seriously for years. Work by Ahmed Almhiri, Daniel Harlow, and others has shown that the holographic principle, the strange idea that everything inside a region of space can be encoded on its boundary like a cosmic hologram, follows the structure of a quantum error-correcting code with an accuracy that should not be possible by chance. Sit with that for 1 second. The universe behaves as if it is protecting its own information. The fabric of reality looks engineered the way you would build a system that is never ever allowed to fail. Designed to preserve, designed to be robust, designed to survive its own noise. And the machine we built to peer into the quantum frontier runs on that exact same principle. A device founded on quantum error correction, reaching into the quantum guts of reality and finding the same fingerprint staring back at it. That is the response no one in that room was prepared for. Not a sentence, a symmetry. And once you have seen it, you cannot unsee it. And only music gets stranger from here. Engineered to last. Let me be precise because precision is the whole game here. The patterns are real. The math is real. What the patterns ultimately mean is the part nobody has settled. But the resemblance itself is not in question. A universe whose deepest architecture echoes the logic of engineered failsafe. Music, systems is not some fringe daydream. It is something serious physicists are wrestling with right now on whiteboards covered in equations most of us will never read. And it does not stop at error correction. Look at the shapes the universe keeps reaching for at every scale. The same self-repeating geometries that show up in coastlines, in snowflakes, in the branching of your own blood vessels, in the spiral arms of galaxies 100,000 light-years across. The same design sketched music over and over from the unimaginably small to the unimaginably vast. And underneath all of it, the deep symmetries, music that theoretical physicists keep proposing as the possible skeleton of a single unified theory of everything. Structures so elegant that nobody could have laid them down by casual accident. And yet there they sit. A universe that merely looks ordered is one thing. A universe that looks engineered, music, is something else entirely. And the longer you stare at the architecture, the harder it gets to tell which one you are actually looking at. The simulation problem, which drags us straight into a conversation that has been getting louder in physics and philosophy for 20 years, the simulation hypothesis. In 2003, the philosopher Nick Bostrom published a paper built on an argument so simple it is almost rude. He laid out 3 possibilities and insisted that at least one of them has to be true. Either almost every civilization wipes itself out before it ever gets advanced enough to simulate whole realities, or almost music, every civilization that reaches that power decides for reasons of its own never to run those simulations. Or, and this is the door that keeps physicists awake at 3 o'clock in the morning, we are almost certainly living inside a simulation right now. The logic is brutal once you follow it. If advanced civilizations do run detailed simulations of reality, and if they run a lot of them, then simulated minds would massively outnumber the real ones. Music, any conscious being chosen at random, you sitting there right now reading these words, would be far more likely to be one of the simulated billions than one of the rare originals. This is not a forum post scribbled at midnight. It is a paper in a peer-reviewed philosophy journal cited thousands of times. Elon Musk has said in public that the odds we are not in a simulation run about 1,000,000,000 to 1. Neil deGrasse Tyson has put it at roughly even money in front of a room full of scientists. And Max Tegmark, the cosmologist at MIT, has built an entire framework on the idea that reality at its deepest, music level is not described by mathematics, but actually is mathematics, made of it all the way down. And if reality is made of mathematics, then the question, music, of who built it stops sounding like theology and starts sounding like engineering. Because who writes mathematical structures? Who designs systems with error correction baked into the foundation? Who tunes the settings so carefully that the whole thing holds together instead of falling apart? Those are not questions you ask a priest. Those are questions a programmer asks. The Goldilocks numbers, which lands us on the piece of physics that has quietly terrified cosmologists for decades. The fine-tuning of the constants. The numbers that run our universe sit at values so precise that the smallest nudge would have erased everything. The cosmological constant, the energy baked into empty space, is tuned to a precision of about 1 part in 10 to the power of 120. That is a number so insanely exact that physicists have burned entire careers trying to explain it away and have mostly failed. The strength of the nuclear forces, the pull of electromagnetism, the ratio between the mass of an electron and a proton, every one of them sits at a value that looks chosen, picked out of a range of possibilities so vast. Music, it had no business landing anywhere useful. And yet it landed precisely where a universe can work. Move one of those dials by a sliver of a percent, and there are no atoms, no stars, no chemistry, no life anywhere ever. The constants live inside a razor-thin band where a universe capable of doing anything interesting. Can music exist at all? Not too hot, not too cold, not too orderly, not too chaotic. Everything balanced on a knife edge and balanced against staggering odds in 3 answers. So, what does all of it actually mean? There are 3 serious answers on the table, and honest people are fighting over every one of them. Let me walk you through them the way the researchers do. The first answer stays closest to safe, established physics. The universe is mathematical. The patterns are real features of the quantum fabric, but they do not need a builder. They just mean that mathematics is, in some deep sense, more fundamental than physical reality itself. The universe is not described by math. It is math, and math needs no creator. 2 plus 2 has equaled 4 in every possible universe that could ever exist. The elegance we keep finding is just the elegance of mathematics being itself, eternal and self-consistent, with no engineer anywhere in sight. It is rigorous, it is careful, and plenty of brilliant people hold it. The second answer is more radical and more scientific than it has any right to sound. The universe is a simulation. The patterns are not coincidences. They're the fingerprints of code. Reality runs on something like a quantum error-correcting algorithm because, at the very bottom, it literally is 1. The fine-tuning of the constants is not a mystery at all. It is a setting chosen by whoever wrote the program. The reason the quantum world feels so alien, so impossible to picture, is that it sits closer to the underlying code than the cozy world of tables and chairs and morning traffic. And a machine that works at the quantum level is, in this view, doing something staggering. It is touching the base layer of the program. If this one is true, then who built the universe has a literal answer. And it is not a god in any old sense, but something closer to an engineer, a programmer, a civilization advanced enough to build a cosmos and let it run. The third answer sits between the other 2, and it is the one I find hardest to shake. We do not know, honestly, rigorously. We do not know. The patterns are real. The fine-tuning is real. The elegance is real. The fact that our best quantum machine seems to compute in ways that strain a single reality is real. But whether all of it points to design, or to mathematics, or to something we do not yet even have words for lies past the current edge of science. And sitting still inside that uncertainty, instead of sprinting toward whatever answer feels safest, might be the most honest thing a human being can do right now. We do not know. But for the first time in our entire history, we finally have a way to start finding out. A new kind of lens. Because the real revolution here was never going to be a tidy answer. The real revolution is that we now hold a tool for the first time in the history of our species that can probe questions this deep. A tool that works at the exact seam where physics touches philosophy, where mathematics brushes up against meaning, where the line between the universe and the mind trying to understand it goes genuinely soft. For thousands of years, the origin of reality belonged only to faith and philosophy. Then science showed up and slowly, painfully, brilliantly dragged those questions onto solid ground. Darwin showed how the staggering complexity of life could arise with no designer at the wheel. Einstein showed that space and time themselves bend and stretch. The Big Bang handed us an origin of a kind. Quantum mechanics revealed that, down at the smallest scales, reality is woven out of probability, stranger than anything our senses were ever built to handle. But none of those tools, music, could reach this deep. None of them could probe the mathematical structure of reality from the inside the way a quantum machine finally can. And here is the part that should keep you up tonight. Willow is a prototype, a proof that the principle works, that the engineering is sound, that the road ahead is real. Google's own roadmap lays out milestone after milestone, each machine more powerful and more precise than the last, climbing toward a fully fault-tolerant quantum computer with potentially millions of stable error-corrected qubits. A machine that, set next to Willow, would be what a modern supercomputer is to an abacus. What would that machine find, turned loose on these same questions? What structures invisible to Willow might snap into focus under a sharper quantum eye? Nobody knows. And that may be the most electrifying sentence in all of science right now. The response. So, think about the moment we are standing in. The last time humanity built a genuinely new lens, when Galileo tipped a crude telescope up at the sky and saw moons circling Jupiter, the comfortable belief that everything revolved around us simply died. And every single time since, when we built a sharper way of seeing, the universe answered the same way. When the first microscope was turned on a drop of water and Antony van Leeuwenhoek saw it swarming with living things, the invisible world turned out richer than anyone had dared imagine. When telescopes resolved faint smudges of light into entire galaxies, the cosmos turned out 1,000 times larger than we believed, packed with 100 billion of them. When physicists cracked open the atom, they found a whole zoo of particles obeying rules that mocked every intuition we had. Every time we built a sharper lens, reality came back more extraordinary than we expected. Nevertheless, Willow is that kind of lens aimed not at the very large or the very small, but at the very deep, at the mathematical bedrock of reality, at the place where particles dissolve into probability, where physics turns into information, and where the universe becomes, in some sense, a question asking,